602 is usually a complicated lesson for calculus students, especially the first time around. So don't let it get to you. Just keep trying. Practice as much as you can. It's very visual, so I'll try to make that easy for you to see. Khan Academy has some really good videos that covers this topic as well. Okay, let's do our first example. Find the volume of the solid formed by rotating the region bounded by the graph of y equals 1 plus the square root of x, the y-axis, and the line y equals 3 about the y-axis. So this is a volume of revolution. This creates a three-dimensional shape. Let's draw a picture of the situation. So we have our y equals 1 plus the square root of x right here, the red graph, and y equals 3 and the y-axis. So we're rotating this little piece right here, and we're rotating it around the y-axis, which means we need to integrate with respect to y. So we're going to need to solve this equation for x, because all of these radiuses, I love that word, radii is really the plural, are going to need to be horizontal. So if you picture spinning this around, this shaded area, this pink area that I have drawing in right now, spinning it around the y-axis, it creates a three-dimensional shape, kind of like a pyramid looking thing, something like that. Upside down pyramid, I guess, but not quite triangular, more curvy. Maybe like a volcano that doesn't have an opening in the center. It comes to a point instead. So anyway, all of these horizontal lines here represent the radius of the circle that we're creating by spinning. So this thing spins around, and it's a radius of a circle. So the radius in this case is a horizontal distance, which means we need to measure it based on the x-axis. So we need to solve this equation for x, which means we'll subtract 1 and then square both sides. So it'll be y minus 1, and then we'll need to square to get the x by itself. So x equals y minus 1 all squared, and that represents the radius. And because there's no hole in the center, this is a completely solid figure. There's no gap in the middle. This is called a disk, because this circle is solid here. There's no hole. We'll talk about that in the next one. It's a washer method. So the formula for this is just pi times the radius squared. And you could put the pi here, or you could put the pi out front because it's a constant. Either way. And I put a dy here because we're going to integrate with respect to y, because we're dealing with horizontal distances here, or horizontal radius. So our radius is literally y minus 1 squared. We're going to plug that in right here, right in that set of parentheses. So nothing too tricky this time. So y minus 1 squared went right in here, and we still have to square it. There's two squares now, so you can simplify that and get y minus 1 to the 4th power. And this is happening from 1 to 3 on the y-axis. Okay, so before you start multiplying this whole thing out with 4 y minus 1s and foiling and distributing and going crazy here, you can use substitution on this problem to integrate. The u is y minus 1. The derivative of u with respect to y is just going to be 1 dy. So we can replace this piece with a u and the dy with a du. So you can rewrite that integral with, it'll be u to the 4th du, but be careful because these limits of integration belong to the y. So let's make it belong to the u instead. So you plug in a 1 into this expression, and that's our new lower limit. And then you plug in a 3 into that expression, and that's our new upper limit. So anytime you use substitution, you have to remember to change the limits to match the u's. So let's rewrite this. You'll have u to the 4th power du from 0 to 2 now. And that's so much easier to integrate. No algebra involved. U to the 5th power over 5 from 0 to 2. Just plug in fundamental theorem and simplify. Okay, aside from that being integrated around the y-axis, this is a pretty straightforward volume problem. There was no hole in the center. We just had to find the radius. In this case, the radius was the x coordinates of this graph. So we had to solve this for x. Let's do the same problem again. Let's change it to the x-axis instead. So find the volume of the solid formed by rotating the region bounded by the same graph, the y-axis, and the same line y equals 3 around the x-axis this time. So here's our picture going this way now. So imagine taking this section here, all of this, and spinning it around and around and around. There's going to be a hole. There's actually a gap from 0 to 1. And then if you think about the symmetry of this, it's going to be like -1 down here. You're still going to have a hole. It's going to be a pretty large hole. And it curves out like this. So this one has a gap in the center. This is called the washer method. This will look something like this. Let me help you visualize. Because this piece is straight, this is the outer piece. We're going to have what looks like a cylinder, like a soup can on the outside of the three-dimensional shape. So it'll look like a soup can on the outside, but on the inside, it's going to look like a bowl. And then there's a hole in the center. So it's like a bowl or a sink maybe. And then there's like a hole, a big drain in the center. That helps. Okay, so this one is considered a washer situation because of the hole in the center. And this one is the outer radius minus the inner radius, or you can say the longer one minus the shorter one. So, and we're integrating with respect to x this time. We're going this way. So our radiuses are going to be vertical this time. So we can keep things like the way they are, y equals, because we're going to have vertical lines to measure along the y-axis. And the outer radius, which is the longer one, in this case is y equals 3. It's a constant, y equals 3. But the inner radius is that square root function. So when you take the outer minus the inner, that gives us this section in between, but we have to separate them this time because we're talking about a washer volume situation. So be careful when you spin something around and there's a gap in the center of it, then that means you have to square them separately, treat them separate. You still do outside minus inside or top minus bottom. It's the same thing as the last section. 601 is a really important section because it teaches you how to find the area between the curves. In this case, we just have to remember if there's a gap, we have to split them up into two pieces and square them separately. So the outer radius is 3 squared. The inner radius is going to be 1 plus the square root of x squared. And then in this case, we're going along the x-axis, so our limits are 0 to 4. And now this one, we're going to need to FOIL this. We can't use substitution. If you try to use substitution on this one, like this is just going to be a 9, so that's no problem. But if you try to integrate this one using substitution, you don't have what you need. You end up with too many things. Like the derivative of 1 is 0, but then you end up with this, which is really 1 over 2 square root of x, and this is too much stuff. Like we don't have a square root of x. This is our u. This would be u squared, and all we have left is a dx. And we have this going on here. We can't do this. So this one you actually have to FOIL out. And if you do that, 1 plus the square root of x times itself, 1 for the first one, square root of x times the square root of x for the last one, and then square root of x times 1, 2 of those for the middle. Okay, simplify this a little more, as you can get an 8 right here, and then integrate that. This is 2 times x to the 1/2 power. It's always nice to see that as an exponent, because when you integrate that piece right there, you're going to add 1 to it. You'll end up with 3/2, 2 times x to the 3/2 over 3/2. Or if you remember, you're just going to multiply by this reciprocal. So it'll be 2 times 2/3 here. You're going to end up with 4/3 on this one. 2 times 2/3. So this is 8x. This is going to be x to the 3/2 times 2/3 times this 2. And then this is x squared over 2. Simplify that. And then plug in your 4. Zeros makes it all go away. Simplify a little more. This is really the square root of 4 cubed. And the square root of 4 cubed is the square root of 4 times itself 3 times. So that's really 2 times 2 times 2. That's an 8 right there. So this is 4/3 times 8. So now we have 32 minus 8 gave us the 24. And then this piece right here is that 32 over 3. Getting a common denominator so we can get our final answer here. Again, you might do that algebra a little differently. I try not to use a calculator. This would be a non-calculator type question, so it's always good to be real handy with radicals and things like that. Okay, so those were 2 basic disk and washer methods. We're going to do this problem again. We're going to rotate around a different horizontal line and a different vertical line in the next video.